The lunch will be right after our test, and then they'll have some more information if you can hang out the rest of the afternoon, but you don't have to feel like you have to stay the whole time. We'll have lunch available at 1 o'clock, and then we'll discuss registration and other questions you might have, and whatever else Natalie has to share with you. So just remember, give yourself plenty of time by coming in at 11 next Tuesday. 1 o'clock will be lunch. You're scheduled to go through 4. But like I said, just hang out as long as you feel is appropriate the rest of that day on Tuesday. Okay? So I have this packet for you that concludes all the types of problems that you will likely see on the test. So focus your attention now on just these problems and also online where you see Pelican Prep Math Accelerator Practice Assessment. That one assignment that says practice assessment in your to-do list, not the one that says fall, but the one that says practice assessment. That's another set of problems just like these, but with different numbers. This is my printout of numbers so that we can follow along together today. That online set is one that you can use to practice inputting your answers and to also get some different numbers to practice with. So let's just go ahead and start with the top, number 1. And I might skip around a little bit depending on if we get things that are kind of repetitive, because there are a couple that I need to show you we have not seen yet. First one is adding fractions, 5/12 plus 7/16. What do we have to do when we are, excuse me, adding fractions like this? Got ghost in the room. Common denominator is important when we're adding or subtracting fractions. So with 12 and 16, what are our options? 2 and 4 are numbers in those two. What else? Is it 3 in that 12, right? So we need some kind of 3 involved as well. 3 times 2 times 4, that's 24 so far. Will both of them go into 24? 12 will, but 16 won't. So how about we double that and see if that works? 48. That works. If you're not sure, divide these and see that they give you a whole number. This gives us 3 when we divide 16, 4 when we divide 12. So to get up to 48, we're going to do times 4 here, times 4 here for 20. 16 times 3 gets us to 48. So we do a times 3 on the top number. That gives us 21. And add across the top for 41. And 48 goes on the bottom. Questions? Yeah, we were just kind of brainstorming factors that were in 12 and 16 there, multiply them up to see what number we got. And that was 24, but 16 doesn't divide evenly with 24. So I just kind of gave the guess, okay, what if I double that? Will it create a number that both of them can divide. Now, if you want to be a little more precise, write down your multiples of each. 12, 24, 36, 48, 16, 32, 48, then you can find a match. And this was times 1, times 2, times 3, and 4. So that gives you your numbers as well. 3 times 16, that's why we use 3 times to scale this fraction. 4 times 12 is what gets us to 48. So that's why we use 4 to scale that fraction. The next one we have log in the given value. If b is 3 and c is -5, what do we get for b squared minus c squared? 3 squared minus -5 squared. What do we get for 3? 3 times 3 is 9 minus -5 times -5, that's positive, and 25. So subtract those two, we get 16 for the negative on it, and 25 is larger. Say that again. Yeah, you don't need over 1 necessarily. Yeah, so you're given these two numbers. C, when b equal 3 and c equal -5. Yep. So we weren't expected to come up with those values. Three, what's the absolute value of -92? Absolute value is a little bit different operation. We're not looking for the factors, like the numbers that will go into it. What are we doing when we look at absolute value? And take what exactly out of here? Well, I agree with the 92. What about I find? Do we need to carry that with it? Percentage is positive. The action that we're taking here with these signs is like making it positive, regardless of whether there's a positive or negative number in there. So absolute value of 92 is not taking the opposite. I don't take -92. That's also 92. Take the positive of that quantity. Yeah. Yeah. Just taking the positive of that number. You can think of it kind of like the distance from 0 to that number. If we went to the left 92 units, we would land at -92. Similarly, to the right 92 units, we would land. These are our final answers right here. In those two cases, if I'm taking the absolute value of negative 92, my final answer is just 92. Same here. Yeah. Now recognize that that's absolute value of some number. We've talked about absolute value in a different context, solving them, where we break out number one, number two, solve them separately. So don't mix up the two ways of dealing with absolute value. This is absolute value of a number, not equation. Square root 96. I think this is the process you were thinking of, Sharita. Here, we need to do what? Yeah, break it down. And so start your process. 96 can be broken down as 2 times 48, 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3. Let's see how much we can pair off. 1, 2 pairs of 2s. They're coming out. 2 and 2. What's left in there? 2 and 3. And clean up the little factors. 4 is on the outside. 6 and 2 times 3 on the inside. Yeah. These two give us 4. Yep. Those 2's came from the pairings. And then the ones that weren't paired off stay in there, multiply together, then give us 6. I don't know why they have multiple boxes on a lot of these problems. Just assume there's one box. For some reason, when I print it out, it creates duplicate boxes. We're asked to factor this expression on number 5. So remember, we want to do this number. What factors of 98 will add to negative 7? Now that's not easy. 98 and negative 7. 2 times 49, that's not going to work. 2 and 49 add up to 47. Isn't there a difference? So factors that multiply up to 98 and then subtract to 7. So we tried 2 and 49. Their difference is 47. Shouldn't write it that way. Do comma. And I'm going to say times up to 98, and then their difference here is 7 times what? 14. And that difference is 7. Now I need it to be negative. I'm going to put my negative on the 14. So they add up to -7. 7 times -14 will give us a -98. And then 7 plus -14 will give us a -7. Those are our factors now. +7 and -14. I played a little magic trick there. By looking at this, I see there's a 7 somewhere in that number. 7 times 7 is 49. So that's why I went to 7 next. Okay. So if you can see stuff like that while you're working, that can save you some time rather than doing 98 divided 3, 98 divided 4, 98 divided 5, 6, then 7, and finally find what? Yeah, divide 2, you get 49. And then if we divide it 3, 4, 5, 6, we would get a decimal with 98. 98 divided 7 gives us 14. So you're doing that division to see if the other is a whole number. And if so, then that's a potential candidate for your factors. This is the one that works. I'm just going to put negatives in here because we need -98, right? And then when you figure the difference, we're looking for -7. We got an inequality, the next one. So we solve this just like an equation, move things from one side to another to get it to x by itself. I might start with, say, plus 4x. Or you could just as well start with something like +6 on both sides, either way. This gives me a 7x. I bring down my -6, and that went away. I'm left with 36 over there. Now I'm going to add this 6, bring it with that 36. Got 7x left over here, 42 here. 7 times my variable, need to undo that with dividing 7. Then x is greater than or equal to 6. 42 divided 7, we can do in our calculator. Then sketch out what this looks like from 6. Want to be greater than or equal to. So greater than, equal to, remember, is square bracket. I'm going up indefinitely. I go to infinity, and I use a parenthesis on that infinity. Then we started from 6 with square bracket and went to infinity. Close paren. There is my final answer right there in interval notation. -6 quantity squared. Remember, if I have something in parentheses and then an exponent on it, then I apply that to everything in the parentheses. So I put -6 times -6. Everything in here, 2 times over. What's that? Positive. And 6 times 6 is 36. The next one we have not done in class, but you may have practiced some of these on your own because it popped up in the homework. Find the slope of the line passing through these 2 points. Okay? To find the slope, what we do is we take the y coordinate, the second digit, and subtract them on the top. 3 minus 8. 3 minus 8. Then I take in the same order the x ones, the first one, and subtract them. Same order. -1 minus -8. The only reason I'm putting those parentheses right there is because I have a minus and negative. I separate them. Then I can go ahead and do that top part if I want. That's -5, right? 3 minus 8. If you have minus and negative, it's a good idea to change that to addition. Think of it like negative times negative, create +8. Then handle that bottom piece, -5 over, it's like +7 here. -1 plus 8, +7. -5, 7 is my slope for that example. I can do it the other way around. So this is same answer, other way around. 8 minus 3. I just have to set up my bottom piece in the same order this way. -8 minus -1. If I do this way, 8 minus 3, then my bottom needs to be this way as well. -8 minus -1. Get 5 over -8 plus 1 is 5 over -7. Same answer. My negative just popped up in a different place, but one negative sign somewhere in a fraction just means it's negative. It doesn't matter where it is necessarily. Both of those equal -5/7. You'll get the wrong sign. You'll get +5/7. Yeah, think of it like same direction. Same direction. There are other strategies you can apply for slope. For example, I could put them like this. And that kind of forces me to keep them in order. 3 minus 8 is -5. -1 plus, because I have 2 negatives here, -1 plus 8 is 7. I just have to remember when I take this information that it goes that way. That's the only thing that is lost in setting it up that way is you don't have it in this fraction form when you're doing it that way. -1 minus -8 is the same as +8. Yeah. let's do the other one for slope. You turn to number 39. The 2 points we have are 7, 9, 7, 9, and 7, -8. So if we set them up with 9 first, then minus -8, then I do 7 minus 7. I get 9 plus 8 across the top, 0 on the bottom. So 17 over 0. Is that good? It's unfortunate. Yes. It's unfortunate to have a 0 in the denominator. We say that that is undefined. Yeah, 0 on the top means it equals 0, but on the bottom means it's undefined. And you see there in the instructions to type in the word undefined, if that's what you find. Let's do one where it works out the other way around. So I'm going to do alternate number 39 with 9, -3, and 7, -3. Okay. Slope, in this case, -3 minus -3 over 9 minus 7, less -3 plus 3, and that's plus, over 2. I get 0 over 2. 0 on the top means it equals 0. Equals 0 instead. Okay. 0 divided by something is always 0, is the idea. Something divided by 0 is, we don't know. If it's just subtraction, like here, or let's say you're setting it up and it turns out to be -8 minus 1. You got to think about that a little bit differently. It's -9, right? If the subtraction were such that it were -2 minus -1, then that becomes -2 plus 1, which is -1. Or -1. And so there's all sorts of combinations that you could come across. What I'm doing here, let's just write it down for reference, is -2, -8, and -1, 1. So we did -8 minus 1 across the top, -2 minus -1 across the bottom. And that works out that way. Now this is equal to positive, since I got two negatives. Yeah. And I can also just write that as 9. Either way is fine. If you entered this way, also just as good. Just be ready for any order of subtraction, something like that. We explored almost all of them, if not all of them, like minus a negative, minus just the number, minus a negative, minus just a number, negative minus something, negative minus a negative. Yeah, all those could be possible. Let's go back to number 9. Where we see x such that x is greater than 3. We want to write this in interval notation. I would first recommend you sketch it out. From 3, we're looking greater. I also don't have my equal bar, so that means I'll use a paren. I'm going up indefinitely, so I use an infinity over here. That always gets a paren. And so now I'm ready to write my interval paren 3, comma, infinity paren. So anytime you have just the sign no equal bar, you're going to use parentheses. You're also going to use parentheses anytime you're going to infinity or negative infinity. Okay? You'll use square bracket when you have the equal bar. But only on the number side, not the infinity side. Some of them can have square bracket on one side, parenthesis on the other, you know. Yeah, if we use the square bracket here, it would be incorrect. Yeah. Let's say it is less than or equal to -7. From -7, I'm going less than. I have a bracket on -7 since I got the equal bar there. And over here, I paren down to negative infinity. And so there, my interval looks like that. Bracket. Mm-hmm. Yep. 10, where we are dividing 15 y squared minus 12y, all with 3y. Yeah, less than or equal to, so less than come left of the number. Always use parentheses on your infinity side. Yeah. Any infinity sides, you'll always use parentheses. A two bracket example would have to have numbers on either side. For example, from -3 to 2, like that. Then I'm going -3 to 2. For dividing a single term, I recommend going ahead and writing out both or all of the things on the top over that term, like that. We have 15y squared minus 12, all divided by 3y. Then you can focus on each one. I can divide 3 evenly here, and I'm left with 5, right? That's 5. And then I can divide 1y from here. I'm left with 1y. Minus 12 divided by 3, that's 4. And my y's divide evenly. So no y's left. It'll be kind of like random scramble, like the ordering that we're seeing here. Hmm? What? Some people from the 5:30 might come at 11, but they may choose to take it at 5. We invited everyone just in case they want to be here for their lunch right after, but not everybody can make it at our 11 time. Yeah, we'll be in here. Mhm. For that 11, we're to find all the factors of 80. So tell me, describe for me how you might approach that. Find all the factors of 80. Okay. 2 times what? That's fine. Divide 2, what do you get? 40. The 2 and 40 are factors. 2 and 40. And what other ones? 8 and 10. 8 and 10. 4 and 20. Are we missing any? 3 doesn't divide. Does 5? I think it does since it ends in 0, right? 5 and what? 16. also 1 and 80. So unlike prime factorization, when we're looking to write out like 2 times 2 times 3 times 5 or whatever gets us to the number, if we're writing down all the factors, then we literally list all of them. And I recommended looking at the pairings, like 2 and 40, 8 and 10, and so forth. I'm just going to rewrite our list so we can clearly see all of it. We have it all there. Nine, 10, 15. 7 won't go, 8 will, 9 will not. 10, 11 will not, 12 will not. 13, 14, 15 will not. 16, and then we're back around. So you kind of have to work up the list until you get to the middle somewhere. 16 and 5, we've already paired off. And so when we get to testing 16, we don't need to keep testing more higher. All right, test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's already come up. So I can stop testing at that point. Now we tossed 3, 6, 7, 9, 11, 12, 13, 14, 15, because when we divide those, they give us a decimal, not a whole number. Now, when you're coming up with this list, you can feel free to just write it this way, if that's easier for you. See what I'm doing? Instead of in chronological order, I'm writing them as pairs. 1 times 80, 2 times 40, 40, 4 times 20, and so forth. So you can do that way if that's better for you. And actually, if you do it that way, notice you get kind of centered right there in that last one. 8 times 10, you test 9 and see that it doesn't work, and then your next number is 10, well, you've already got it. So that's an indication to stop. Okay. So to factor 5x cubed plus 10x squared plus 15x. The first thing you should notice about that is that x is in every term. So it's got to come out, leaving us with a different set of 3 terms. Now, before you do that, though, ask yourself, are there any other pieces, like numerical pieces, that can come out? Do 5, 10, and 15 share any factors? 5. So that can also come out, making the factorization of this easier. Okay. Now, what's left over is x squared from that first term, 2 to get to 10, right? And 1x left over, 3 to get to 15. I've already got my x. So no x on that last term. We've already got one x represented. Now I turn my attention to this part. Can I factor this? Can I multiply up to positive 3 and add to positive 2? 1 times 3. Nope, that gives me 4. I add this. So that can't be factored. You know, sometimes we keep on working and we get this, but that's not going to happen here because we can't figure out that puzzle. So we come back here and say this is the stopping point. $13. A nice little break. We have square root 5y squared. Okay, let's write that thing 2 times over within the parentheses. We know when we're multiplying square roots, we can treat it all up under 1. Right? 5 times 5 times y times y. And we've got all pairs going on here. So they're coming out. 5y, nothing's left in. $14. We're to factor x squared plus 3x plus 2. And that is looking for multiples of 2 that add to positive 3. 2 can only be gotten by 1 times 2. And that does add to 3. So we do have factors in this case. We'll go in this direction. Some more down here. We read off our factors from here. Plus 1, plus 2, and we've got x's. So x plus 1 and x plus 2. If we had been able to factor back here, then we would have written 5x times whatever. So we weren't able to factor on that. The puzzle didn't work. It does work here, so we go that last step. Yeah. The middle goes on the bottom. Mm-hmm. Yeah. We want to solve negative 12 equals 3 plus x. What should we do? We get x by itself. How do we undo that? Yeah, we have 1x. Mm-hmm. So our focus should be here, getting that away from that 1x. Right? We can treat that like positive 3, so it can be made 0 by subtracting 3. Subtracting 3. That combines for negative 15, and then that's going away, leaving us with x. You can eyeball that, plug it back in, 3 plus negative 15. That does give us negative 12. For number 16, we are just tasked with simplifying the expression. It has 23x minus 5 times 6x plus 2. This stuff can't be combined in here, so what do we want to do? Do what? Yeah, what can we do there? You got scrambled terms in here, unlike in the distribution. Negative 5 times 6x, negative 5 times 2. So that gives 23x minus 30x minus 10. And then these two terms are alike. 23 minus 30, that's negative 7. I want to stop there since those are unlike. One's got an x and the other one doesn't. Negative 7x and a minus 10. Multiplying fractions by 16th and 9th. What should I do? Look for common factors maybe, but not so far as to find a common denominator in the case of multiplication, right? If we're multiplying or dividing fractions, it's not critical that we make the same denominator. We can, it's an extra. It's only required when we're adding or subtracting the fractions that we create common denominators. What I would try, if I were looking at multiplication, is I would write all the numbers on the top as if they're multiplied together, all the numbers on the bottom as if they're multiplied together, and then ask myself, do they share factors? This one and this one, no. This one and this one, yes. So divide 8 out of 16, that gives me 2. And divide 8 out of 8, that gives me 1. So now I just have 5 times 1 on the top. 2 times 9, 18. Negative 22 plus negative 47 plus negative 14. What should I do if I have that string of addition? Negative plus negative plus negative, that's just going to be adding all those three numbers together, and it's going to be negative, right? add a bunch of negative numbers together, then that's just making it more and more negative. Let's add those first two, 69 plus that last one, negative 14. That gets us to 83. You don't have to do that two-step. You can just enter all of that into your calculator once. Negative 22 plus negative 47 plus negative 14. Now where it can get tricky is how do you enter negative on those numbers? There's a negative key near the bottom of your calculator that you have to press instead of the subtraction symbol. Use a negative symbol. We've done one like number 19. Then number 22. If f of t is t cubed minus 3t plus 6, then what is f2? So this means we're going to plug 2 in to the place of t. So 2 cubed minus 3 times 2 plus 6. And then I evaluate that. 2 times 2 times 2 is 8. Minus 3 times 2 is 6. Plus 6. And I can see over here that's 0. So I'm left with 8. Or if I did it left to right, 8 minus 6 is 2. Plus 6 is 8. Another one like that is number 31. We have f of x equal 5x minus 4. Then what is f of negative 9? Likewise, in the place of x, we're putting negative 9. So 5 times negative 9 minus 4, that's negative 45 minus 4, negative 49. Here, number 36. If we're to simplify 5 times n minus the group 4 minus 6n, got to be careful with a subtraction sign in front of or a negative in front of parentheses to distribute that negative sign. So negative 4, and then a negative times negative 6 is a positive 6. Then got 5 and 6, both positive, so they add to 11n minus 4. So as if we're distributing this negative first. That's what makes the -4 and then +6 in. Then we're combining these two since they're like, yeah, the in terms. Once we get here, we have to resist the temptation to say something like that, because they're not alike. Okay, number 40. Multiply square root a to the fifth, b to the third times a, b to the third. Bring a ball up under 1. A to the sixth, 5 and 1. B also coincidentally to the sixth, 3 and 3. And then remember how we handle those exponents. If they're even, we slash them in half and bring them out. So a to the third, b to the third. Some of the side work you consider there. Slash in half, pair off. B to the sixth is slashing in half so that it pairs off. Number 45 is to graph negative infinity to 5. We haven't practiced with the graphing tool a lot, but basically what you want to do if you're asked to graph something like this is to click on the square bracket option to go on 5. And so click on the square bracket and place it on 5. Then there's a marker button. I think it looks like a pencil kind of thing like this. And then you would click here so that it colors in that region. And you'll see it highlight this way once you do that. And that indicates from 5 to negative infinity. If we put square bracket facing this way, and then we color the line going to the left, that's what we're looking to graph. '46 has that double-sided number interval. We looked at one like this earlier. Notice this one has two different symbols. One has the equal sign, the other one doesn't. And so from -8 to 5, this one has the equal sign, so I use bracket. That one does not, so I use parent over there. '54, we're graphing again. We're going to do x such that it is between -2 and 1. So these are params here, no equal sign, right? So at -2, we're going to click on the param that goes this way and click there. At 1, we're going to click on the param that's facing this way and click there. And then we're going to do the marker and color in the middle. There are param buttons on the graph. So you got the param button. You're going to click that and then click next to -2. You've also got a param button that faces that way. You're going to click that and next to the 1. And then you've got your marker button. You're going to click that and somewhere in the middle here. If you have questions about those graphing ones on the test day, I'll be happy to assist. Because I know I haven't demonstrated that on the screen to you. I'm just telling you how it works. No, the only questions that are coming out of that section are those on slope that we talked about earlier. The y minus on the top, x minus on the bottom. They took questions exactly from the test. The practice assessment and the packet are all things you'll see exactly different numbers. Yeah. That's why I say, if you can get comfortable with what you see in the practice assessment and practice it on your computer too, in addition to the packet, you're going to take it on the computer on Tuesday. So remember to bring your laptop, practice the practice assessment on the computer. That way you're comfortable with how to enter your answers. You don't have to do the one that says fall practice just yet. Just do the one that says practice assessment.